Hello and welcome to comp452. In this lecture we will talk about multiplexers. A multiplexer is it's a combinational circuit. It's a combinational circuit. It has more than one inputs and only one output. Okay. It connects one of the inputs to output at any given time. So basically what we can say is that at any instant of time, only one of the inputs is connected with the output. It usually has one or more enable inputs. Okay. So let us consider the simplest multiplexer. Simplest multiplexer is a 2-to-1 multiplexer. 2-to-1 multiplexer. And it is also called MUX for short. So let us suppose that the inputs are I0 and I1. So this is one input which is I0. This is the other input which is I1. And here we have only one output. Okay. Now the circuit inside this box will connect one of these outputs, I0 or I1, one of these inputs, I0 or I1, to the output, this output. Okay. And which input gets connected to the output? This is controlled by select lines. So these are select lines. Okay. And then there might be one or more enable inputs. Now, for this 2-to-1 multiplexer, we want that if select line is 0, we want to connect I0 to output. So we want, when select is 0, I0 connects to output. Okay. And when select line is 1, I1 connects to output. Okay, this is what we want. So by the way, let me make it a little bit cleaner. I will move this, sorry, I'll bring this input 1 here, this is input 1, okay. So we have, let's bring an AND gate here, and then we have another AND gate here. So this I0 goes to the input of AND gate, and this I1 goes to the input of lower AND gate. Now this select line, it goes to the input of this lower AND gate, and then after passing through this inverter, it goes to the lower input of upper AND gate. Outputs of the AND gates, they are connected to the inputs of an OR gate, and the output of the OR gate goes to the output of the system. Now you can easily see that if this select input is 0, then the lower input of lower AND gate will be 0, and hence its output will also become 0. But this input, the lower input of the upper AND gate, it becomes 1. So it means that whatever the value of I0, it comes here. And here we have 0, and here we have I0. So this output becomes I0. Okay. But when select input is 1, then this becomes 0, this becomes 0, this input becomes 1, and here we have I1, and here we have I1, and then this becomes I1. Okay. Actually, I should have used a different color, and that's what I'm going to do now. I'm going to use a different color. How about using this purple color? So when select is 1, this input becomes 1, this input becomes 0. So because of that, this output becomes 0. So the upper input of the OR gate becomes 0, and this output becomes I1, and the lower input of OR gate becomes I1, and here we get I1. So you can easily see that if the select line is 0, when select is 0, I0 goes to output, and when select line is 1, I1 goes to output. So this is, we call this 1 bit wide 2 to 1 mux. We call it 1 bit wide 2 to 1 mux. Two to 1, and that's how we write mux. Somehow this stylus is not working very well. So this is a 1 bit wide 2 to 1 mux. Now let's suppose that I have two 4-bit numbers and I want to construct a 4-bit wide 2 to 1 mux. I want to construct a 4-bit wide 2 to 1 mux. This is what I want to construct. So it's very simple. By the way, I should have mentioned that this is the symbol we are going to use for the mux, 0 and 1. So we have two inputs and we have one output, and here we have a select line S. This is input 0, this is input 1, and this is output. Okay, so this is the example, this is the block diagram of 2 to 1 mux, which is 1 bit wide. Okay, so now I want to construct a 4-bit wide 2 to 1 mux. So let's suppose I have two numbers, A3, A2, A1, A0, and B3, B2, B1, B0. These are two numbers, and I want to construct a mux which allows one of these numbers to go to the output. So what I'm going to do is I am actually going to use 4 muxes. 1, 2, 3, and 4. So this is 0, this is 1, this is 0, this is 1, this is 0, 1, 0, and 1. Okay, so I will connect A0 here, A1 here, A2 here, and A3 here. B0 will be connected like this: B0, B1, B2, and B3. Okay, now this will be output 0, this will be output 1, this will be output 2, this will be output 3. I think I'll have to use my eraser to clean up this. Sorry. This is how it should look. Then I have a select line. This is my select line S, and the same select line connects to all 4 muxes. Okay, so you see the select line connects to all 4 muxes. So when select line is 0, O output 0 is equal to A0, output 1 is equal to A1, output 2 is equal to A2, and output 3 is equal to A3. When S is 1, output 0 is equal to B0, output 1 is equal to B1, output 2 is equal to B2, and output 3 is equal to B3. So this is our 4-bit wide 2 to 1 mux. This is our 4-bit wide 2 to 1 mux. So you can easily see how you are going to construct an 8-bit wide 2 to 1 mux. You will just attach 8 2 to 1 single bit muxes in parallel. Okay, now let's move on to our slightly more complicated next mux, and this is going to be our 4 to 1 mux. 4 to 1 mux. Okay, this mux is going to have 4 inputs and 1 output. And let's suppose that the 4 inputs are I0, I1, I2 and I3. So I0, I1, I2 and I3. These are the muxes, these are the inputs, and the output, we are going to have only one output. Only one output. Okay. So how many select lines are needed? You can see that we will need 2 select lines here. Okay, we will need 2 select lines here. So let's say that our select lines are S0 and S1. These are our select lines. Okay. Now this will, we will have an AND gate here. First input will be I0 and the other 2 inputs will be actually why should, I think it would be better if I use bubble symbols. These 2 bubbles and this bubble will connect to S1 and S0 and S1. Okay. Then we will have next AND gate. So one of the inputs will be I1 and then we will have S0 going in here, but S1 will go through a bubble. then we'll have another AND gate. I2 will be its one input. Oh, I'm sorry. I2 will be its one input, and then it will have S0 going through bubble, but S1 going directly. And then we will have fourth AND gate. One input will be I3, and the other two inputs will be S1, S0 and S1. So these outputs of the AND gates will be collected here, and they will be made inputs of a 4 input OR gate. Okay, so we can see that when S1 and S0, when they are 0, 0, output will be I0. When this is 0 and this is 1, output will be I1. And this is 1, this is 0, output will be I2. And this is 1 and this is 1, output will be I3. Okay, so this is our 1 bit wide 4 to 1 mux. Now the symbol of this mux that we are going to use will be let me draw the symbol here. There will be 0, 1, 2 and 3. These are the 4 inputs, and then we will have let's call it I0, I1, I2, I3. This is output, and these are select lines S0 and S1. So this is our this is the symbol of 1 bit wide 4 to 1 mux. Now if you want to construct an 8 bit wide 4 to 1 mux, you will have to connect 8 of these in parallel. So let's see if we have, no, we don't have that much space here. Let's see if I can make a smaller version of this symbol. Okay, let's suppose we have 8 we want 8 bit wide 4 to 1 mux. So the 4 numbers that we have are A7, A6, A5, A4, A3, A2, A1, A0 and B7, B6, B5, B4, B3, B2, B1, B0, C7, C6, C5, C4, C3, C2, C1, C0, and D7, D6, D5, D4, D3, D2, D1 and D0. These are the numbers, okay? So look, this is what that mux will look like. One, two, three, 4, 5, 6, 7 and 8. Okay, so A0, B0, C0, D0, A0, B0, C0, D0, they go in here. A1, B1, C1, D1, A1, B1, C1, D1, A2, B2, C2, D2, A2, B2, C2, D2. Then we have A3, B3, C3, D3, A3, B3, C3, D3, A4, B4, C4, D4, A4, B4, C4, D4, A5, B5, C5, D5, A6, B6, C6, D6, A6, B6, C6, D6, and here we have A7, B7, C7 and D7, okay? And there's only one, this output is called output 0, output 1, output 2, output 3, output 4, output 5, output 6 and output 7. Okay, so the select lines will be 2 for each mux, and the same select lines will be connected to each of the 8 muxes. There's not enough space, so I don't want to draw it, but you know how to draw these lines. So now when let's suppose select lines are S0 and S1, S0 and S1. So when S1 and S0 are 0, 0, output will be output 7, output 6, output 5, output 4, output 3, output 2, output 1 and output 0. These will be A7, A6, A5, A4, A3, A2, A1 and A0. When this is 0 and this is 1, we will have B7, B6, B5, B4, B3, B2, B1 and B0. And when this is 1, 0, we'll have C7, C6, C5, C4, C3, C2, C1 and C0. And with 1 and 1, we will have D7, D6, D5, D4, D3, D2, D1 and D0. So this becomes our 8-bit wide 4 to 1 mux. So this becomes our 8-bit wide 4 to 1 mux. 8-bit wide 4 to 1 mux. And and the symbol of this 8-bit wide 4 to 1 mux will be this is 8 bits, 8 bits, 8 bits and 8 bits wide. So these are the inputs A, B, C and D, and this is the output, and this is also 8-bit wide, and there are two select lines S0 and S1. So this is 0, 1, 2 and 3. Okay. Okay, so now what we want to do is there are commercially available ICs, for example, 74 LSY151 is an 8 input 1 output multiplexer. Let's enhance this. Okay, so 74 LS151, this is 1 bit wide 8 to 1 mux. Okay, this is 1 bit wide 8 to 1 mux, and then there is 74LS157, 74LS157. This is a this is a 4-bit wide this is a 4-bit wide 4 to 1 mux. Sorry, this is a 4-bit wide 2 to 1 mux. This is a 4-bit wide 4-bit wide 2 to 1 mux, 2 to 1 mux. Okay, so what this means is that each of the, for this 74, this, it has only one select line, and this is 0, this is 1, and this is a 4-bit wide input, this is a 4-bit wide input, and this is a 4-bit wide output. So when S is 0, these 4 bits, they go to the output. When S is 1, these 4 bits, they go to the output. Okay. Now these multiplexers, they also have enable inputs, and by using these enable inputs, we can expand these multiplexers. By using the enable inputs, we can expand these multiplexers. Okay, so enable inputs allow us to expand the multiplexers, the muxes, okay. All right, so this was our discussion of multiplexers, and now we are in a position to start designing our 1-bit ALU, and then we will extend it to a 32-bit ALU. Okay, so we are going to stop here, and there we go.